Hello everyone, this is Dr. Hisham Said again. This is the video part 2 of solving this problem. Part 1 dealt with this problem as from the interest table, kind of solving it on a paper basically, and walking through the analysis of this cash flow and calculating the net present value. When we did this in the first video, it turned out to be the net present value to be 226.95 positive, so that was a good investment. In this video I want to walk you through how to analyze the same cash flow using Excel. So if you did not watch this video, please check the YouTube link below to go through the problem, how it is solved in a manual way on a paper, and then you can see how Excel can help for the same cash flow, and we'll see if we are getting the same value of net present value of 226.95 or maybe different. So we'll see, test this hypothesis and put it to the test. So how to start with this problem? First you need to put the values that you have. So as we did in the first video, you analyze the different, break down the cash flow into the different components. So P usually is used to refer to the initial investment in a cash flow. So I have it here as negative 3,250, and that's the initial investment, making a little peeling in terms of from the financial. So you make it a dollar formatting, but actually that negative in accounting makes it between parentheses. That's not the way I want to show it. Usually in a negative cash flow I want to show it as negative. So I'm changing here the format to be currency, and then I don't have decimals, so I will change it to a simplified version of that. So that's the initial investment. I have also the annual return and the gradient series return. So I have here the annual is 250, and then the gradient is 10. My interest is 4%, or decimal it's 0.04, and I'll make that as percent format. And then in here, for all parts of the cash flow, A and G, N is equal to 15. That's not a currency, that's a number. But in some complex cash flows, A can have different N, G can have different, usually A and N have the same N if they are attached or kind of complete the whole picture together. Like A starts with A and then increases over the years. But sometimes a cash flow can have different ends for different parts of it. But in this cash flow we have a simple cash flow, we have the same end for both A and G. And then you start analyzing cash flow by for every year you start to write the cash flow amount in every year. So I have here the timeline is from 1 to 15, and then I need to define what's my cash flow in this cash flow. Let's say here more specifically it is the net cash flow. So I will in this line I will write the values that these arrows, I will basically put them here. So the initial investment happens, which is 3,250, happens at the beginning of year 1. So when I write here 1, 2, 3, 4, 15, that's the end of year. So what I need to do is here is actually move these and then create a column for end of year 0 or the beginning of year 1. So that's the right representation of this cash flow, is that this 3,250 dollars initial investment happens at the end of year 0 or the beginning of the first year. I make it here 0. And then at the end of year 1 we start seeing there's a 250 return. So I wrote it here, back to the initial, I wrote it here, this value, or I can actually link it to the same P. I wrote it here. And then the initial, the first payment of return or revenue is equal to the A value here. So that's what this little arrow here represents, and that's positive. And then the second year I have the same 250 plus G 10. So that should be equal to the previous year plus the G amount here is $10. So that's 260. And then I put it here on purpose that it's dependent on the previous year, and because that's the gradient series effect, is you're increasing the cash flow of the last year by the G amount. So let's be careful about referencing here the cells. So I want that, because what I will do is I will drag this, and it's not the correct, still not the right time to drag yet, because I need to make sure that I'm referencing the cells and using the cells here using a fixed reference. So meaning that when I drag, I don't want this cell reference to be dragged with it. So what I will do, I will stand here. Sorry, I will move to this and then press F4, and that will make it fixed reference to this cell I4. And then when I drag, it will keep dragging the reference to the previous cell, like here for example in the middle. So it will be adding the $10, the same like this fixed reference of $10 to the previous cell. So now that makes sense. Now I end up at year 15 with 390 revenue. That's the 15th year, because I have initially building up of 250, building up $10 increases over 15 years. So 250 plus 10 times 15, so 250 plus 150. So $10 increases over 14 years, because the first year 0 increase, but it's still part of the series of the G. So 250 plus 10 times 14, and it is 250 plus 140 equal to 390. Right. So it's basically this is a representation of that. So this is the net cash flow. What I will do, and when you use Excel analyzing cash flow, is you will discount these values. So discounted net cash flow. So you're discounting it by bringing all the cash flows here in different years to the equivalent value in time 0. So we'll use a function here called PV, present value, and then it has different. Sorry, I'll zoom in. So it has here different fields that need to be filled in. So the first one is the rate, and I have here the rate is 4%, and I'll make that fixed reference because that's a value. When I drag, I don't want it to be dragged with me. And then number of periods. So that's the number of periods that I'm using to discount the cash flow of that specific year. So number of periods here is equal to the year number of that year. So in year, that's 0 here, and we'll see the impact of that for discounted net cash flow for the initial investment. PMT, we'll skip that if we're dealing with a single sum, so we'll skip that. So we'll just do a comma, and then FV is the future value. So that will be relatively the future value we have here. So we have here, should be complete formula now. So again, we have the rate, we have the number of periods, which is for every year it's the year number, and then we have the future value. Future relative to where we will bring all these values to. So let's see the value here. And initial investment, the present value of initial investment is always equal to that value. So the discounting factor here is basically 1. So when I drag now over the years, we see here that the values are decreasing. So that 270 at the third year when you discount it, meaning you take out of it the time that the value that accumulates over 3 years, it will be 240. So basically, if you have the options of getting that 270 at the 3rd year, or getting it now, so that you will not get 270 now, you will get 240. Excuse me. So that makes sense. You're discounting, you're bringing future values to the present, but what you see here is that the signs are flipping. So that negative cash flow initial is becoming positive, and that one positive becomes negative. So what we'll need to do here is actually that's an Excel, the way that the Excel formula works is that assumes you are calculating a present value of a future value that's in the flip sign. So it do that flipping automatically. So what we'll do is going back to the formula and make it a negative, so that will fix that flipping issue, and then drag again, and then you can see here that the values maintain their original signs, but they are discounted over the year. And then going back to now to the whole cash flow, so now the net present value of the cash flow is equal to the sum of all present values of all single sums in that cash flow. So I'm adding up the sum, and then that's 227. If I increase here the digits, 226.95, 226.95. So that's the same value we obtained before using a different approach, which is a paper approach in the interest tables. If you use the paper-based and use the formulas for the interest factors, you should also get the same value. So that's basically the process of using Excel sheet for analyzing a cash flow. First, you need to list the values of the cash flow over the years, and then discount every value in every year, and then calculate the net present value of the whole cash flow as the sum of all these discounted values of the cash flow years. So I hope that was helpful. Once you deal with other cash flows, maybe in Excel there are different functions for the uniform annual series, but basically that's if you apply this process, discounting a cash flow in every year and then sum it up, that works for any cash flow you have. Actually, you don't have to deal with other formulas. So that's basically it. You kind of, Excel is your new friend in analyzing cash flows if you have the option. I hope it was a useful exercise and video for you, and thank you for watching that.